In this video, I want to go over VMware Tanzu's embedded Kubernetes. And when we talk about embedded Kubernetes, what we're really getting at is a self-service model. A world where the vSphere operator over on the right does some minimal configuration to allow the developer over on the left to create their own Kubernetes cluster, all without filing tickets to IT. So let's start by taking the operator's perspective and get into what namespace creation looks like. So we'll start by logging into vCenter. So right away we see the usual vCenter resources. We have our data center, we have our cluster, and we also have a new namespace that's called namespaces. So this namespace contains all of our Kubernetes resources. So if we expand this, we'll see all of the namespaces that we've created that we can hand out to our various organizations and teammates. So in this example, we have our DevOps namespace that also contains enterprise services. Say you're running a GitLab server or a container registry, you can run these services out of a cluster like this so that your entire organization can take advantage of them, and you still have those guardrails to keep everyone in place to prevent unauthorized users from accessing them. Looking a little bit more at this, we can get a high-level view of our Kubernetes cluster. We have 4 VMs that make up the entire cluster. So moving away from this, we can look at what a namespace created for a development team can look like. So in this case, we have a space created for one of our development teams, and we can see that they've already gotten to work creating their own Kubernetes cluster for their own uses. In this case, they have 2 VMs that make up this cluster, and they can access this and they can do whatever they need to do with it. So what does it look like when we need to create a new namespace? Let's make a new namespace and onboard a new team. We'll start by going to Workload Management. We see some of the old namespaces that are already there. And we're going to click on New Namespace. Choose our cluster. We'll come up with an appropriate name for this namespace. We'll go ahead and give it the same name as the team that it's going to be assigned to. And there we go. Our namespace has been created. Now this is just a logical slice of our Kubernetes resources. No clusters have been created yet. So as a vSphere operator, there's still a little bit more that we need to do. We'll start by creating permissions around this namespace. We'll choose who can log in. In this case, we have the group out of Active Directory, and we'll give them the edit roles. So that now, this team and only this team can access this namespace to create Kubernetes clusters. Next, we choose a storage policy that's going to back it for things like physical volumes. And lastly, if your B team is like B teams that we've seen, you may want to put some quotas on this namespace. So to prevent one team from infringing on another team or taking down the entire cluster, we can put some limits on this namespace. And this is at the raw resource level. We're not specifying the types of cluster that they can create. We're just putting a limit on the amount of resources that they can take from the system. So now we have in place our capacity limits. We've chosen a storage policy that's going to back our physical volume requests. And we've assigned the proper permissions out. Now all that's left is to come up with an email to send out to the team to tell them they have access. And in that email, we're going to include a link to this page. And at this page, they can go to download a plugin for queue control that allows them to log into this namespace and to get started creating their Kubernetes clusters. We'll get to that part in just a minute. Before going over to the Kubernetes cluster deployment section, I want to show one more thing where we keep users separated from each other. So looking at this one, if we look at the permissions, we see that the B team and only the B team can edit resources inside the B team namespace. Looking over at our A team, the A team, and only the A team, can edit those resources. So this is how we can keep groups separate from each other and prevent the wrong user from logging into the wrong resource. So let's switch perspectives now and go over to see what this looks like from a developer perspective when they go to create their Kubernetes clusters. So what you see here is vCenter on the left, and now we have a manifest file on the right-hand side. This is a manifest file just like they were working with any other Kubernetes construct. Instead of a pod or a service, the kind here is a Tanzu Kubernetes cluster. Moving down the line, we see the name that we're going to give our cluster, and below that is the namespace where we're going to deploy our cluster. Now the name of this namespace needs to match the name of the namespace that was created for us. Going down the manifest file, we can specify other details like what version of Kubernetes do we want, and for the control plane, we can decide the number and type of VMs, as well as the storage class that power our control plane, and we can do the same thing for the workers in our Kubernetes cluster. Also, especially if you have a home lab set up, you may sometimes have some collisions between the default pod network in your cluster and maybe your home network. You can override that by supplying some additional credentials. So what the developer will do next is log into our namespace that was created for us by our vSphere operator. These are the details that were given to us in the email that the vSphere operator gave to the developer. So we'll log in with our usual Active Directory credentials, and we can see now that we have access to this B team namespace that was created. So now, creating a new Kubernetes cluster is as simple as a kubectl apply command. After we get a confirmation, what's going to happen in just a few moments is on the left now, we'll see in vCenter, start to see our VMs get created that are going to create that Kubernetes cluster for us. There we go. So underneath our B team namespace, we now have our Kubernetes cluster, and the VMs are beginning to be created. After a few moments, we'll see all of the VMs will be created and will be ready to deploy workloads. So this was a simple request just for 2 VMs. We can see right here the only kubectl context that we have is to the B team namespace. Now that we've created our Kubernetes cluster, we'll need to log in again, this time into the cluster that we just created. So we're going to run that vSphere login command again, but this time we're going to specify the Tanzu Kubernetes cluster name in that command. We'll go ahead and authenticate again. And now we can see we have access, in addition to the B team namespace, we now have that cluster that we just created. So we'll change our context to the newly created cluster. And now this is a perfectly normal open source Kubernetes cluster. We can get a list of the nodes that are available. Anything that you can do to a normal Kubernetes cluster, you can do here, to include launching a workload. So we're going to create a simple deployment and expose it with a service. Let's get a listing of those pods. Pods are up and running. So it was exposed with a service. We're going to grab the IP that vSphere created for us. And if we put that in our browser, we should see our workload. So we've successfully deployed this workload to our cluster. And if we look at the pod ID, we can see that it corresponds to the output from our kubectl get pods. Refreshing the page confirms that yes, we are getting sent to different pods to show that we do have a true deployment out. And there you have it. A simple workflow where your vSphere operators can enable your developers to create their own Kubernetes clusters and launch their workloads on top of those clusters, all inside vSphere. Hope this was useful. Thanks again for watching.